Hi, Assalamualaikum and a very good morning. So now we are in chapter 2, atomic structure. And now we're going to focus on the subtopic of 2.3 electronic configuration, part 2 of the video. So in this video, we're going to learn on how to explain the anomalous electronic configuration of chromium and copper. So anomalous here means it is abnormal or weird electronic configuration. Okay, and in the previous video, we have learned about the learning outcome of A, B, and C, and we also learned about doing the normal electronic configuration. But there are going to be some exception, which is anomalous cases, which happens in chromium and copper, which is in this video, part 2 of the video. So without any further ado, let us start. So as before, the three rules are being applied for assigning electron to the orbital. So we have the Aufbau principle, we have the Pauli exclusion principle, and we have the Hans rule. However, there are some atoms or ions that do not obey these three rules. And the electronic configuration that do not obey this three rule is known as the anomalous electronic configuration. And this out of ordinary electronic configuration exists for atoms or ions with the 3D orbital. And for our case, specifically, we're going to study for chromium as well as copper. So for now, let us look into chromium first. So anomalous electronic configuration for chromium. So chromium will have a proton number of 24, and at the neutral state, it's going to have 24 electrons as well. So to make your life easier, we start with the SPDF notation first. So we have 24 electrons, so we're going to have one S2, two S2, two P6, so we have 10 already. And then we're going to have 3 S2, 3 P6, 4 S2, and then we have 3 D4. So the total number of electrons here is going to be 24. Okay, so from here we need to put it in terms of orbital diagram in order for us to see the anomalous cases more obviously. So for 1s2, for 1s orbital, we're going to have 2 electrons, so we're going to write it here, 1 and 2. For 2s, we're going to have 2 electrons, which is 1 and 2. And then we're going to move on to the next orbital, which is 2p6. So you're going to have 1, 2, 3, and then we're going to pair them together. And then 3s2, 1 and 2. And then we have 3p6, which is 1, 2, 3, 4, 5, 6. And then we're going to move on to the next orbital, which is 4s2. And then we have 3d4. 1, 2, 3, and 4. Okay. And the SPDF notation here is based on the Aufbau principle. Okay. So according to Aufbau, we're going to fill in the orbital from 1s, 2s, 2p, 3s, 3p, 4s, then only 3d. Okay. And this is something that you predict the SPDF notation to happen for the chromium. But what actually happened was there's going to be a shifting or a transfer of one electron from the 4s orbital, okay, into a 3D orbital. So one electron gonna be transferred from the 4s orbital into 3D orbital. So it's gonna become 4s1 and then become 3d5. And the other part here is not affected. Okay, so what I'm trying to say is that this is what we predicted it to be. But in actuality, what really happened is one of the electron gonna be transferred to 3d5, and this is the actual configuration for chromium, and this is the correct one. And for that reason, we're gonna make another configuration, which is the actual configuration, where one of the electron here from the 4s orbital is being transferred into 3D empty orbital here. And the electron spin here going to be changes as well. So as before, we're going to make an orbital diagram with a labeled orbital. So 1s until 3p is not affected. So you can just write it. You can just write the electron pair again. And then for the 4s, since initially we have two, now one of them is being transferred to 3D. So what we left is 1, and then we're going to have 1, 2, 3, 4, and 5, which is 4s1 and 3d 5. So why is this happening? So basically, one of the electron from the 4s can be transferred into 3d orbital because the energy gap in between the 4s and 3d is very, very small. So because the energy difference is very, very small, it is quite easy for the electron in the 4s orbital to be promoted to the 3d orbital in order to make it more stable. So for a full field orbital, you know that for a complete electron in 3D, we have 3d10. So this is the complete one. Okay, and the reason why we transfer it to here, it is because the half-filled 3d orbital of the 3d5, okay, are more stable than partially filled 3d4 orbital here, in which this provide extra stability. So this is the most stable one, which is the full field orbital, which is completely filled, but 3d5 also provide extra stability in comparison to the 3d4 here. Okay, 1, 2, 3, 4. So for that reason, the 3d5 will be more favorable for the chromium electronic configuration. So that is why one electron from 4s is going to be excited to 3d, and they're going to have the same spin, thus making it more stable. So similar situation can be seen on copper, Cu here. So copper will have 29 electron. So what you're going to get is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we have 3p9 here. Okay, and now we're going to convert the SPDF notation into the orbital diagram. So 1 and 2, 1 and 2, 1, 2, 3, 4, 5, 6. So we have 10 in total, and then we're going to continue again. So we have 18 now, and then we have 20. And then we have the balance 9 here to be filled in the 3D orbital. So we're going to fill it singly first, then only we pair them. Okay, as what you can see here, they're going to have an empty space for an electron to enter. So this is what we predicted it to be. But in actuality, okay, what's going to happen is one of the electron in the 4s orbital going to be transferred into the 3d orbital. So what's going to happen is that we're going to get 4s1 and 3d10. Okay, and this area here, similarly like before, it is not affected. So we're going to write the orbital diagram again, and then we're going to complete 1s until 3p similarly as before. And then for 4s, it's going to become 4s1 because one of these has been transferred into here. So it's going to become 10, 1, 2, 3, 4, 5, and then you're going to pair them 8, 9, and 10. Okay, and the reason is similar to before. Okay, you know that one electron has been transferred from 4s orbital to the 3d orbital, and then this is because of the energy gap between 3d and 4s is very, very close to one another. So it is quite easy for the 4s electron to be transferred into 3d orbital. And this happening due to the full fill d orbital of the 3d10 in copper are more stable than partially 3d9 up here. And this 3d10 will give extra stability. So when it is more stable, it is more favorable for the copper to do so, in which we're going to follow the actual configuration here. Alright, so I think that's all for today's video. See you again some other time. Bye!